Looks like we're ready. We'll go live on YouTube. We are live. Hello, YouTube. And restream. Let me pause. And pause. Live. Thank you, DJ Devin 3. Hi, Pen Pengu. Hi, Fede2 from Costa Rica. Thanks for stopping by. We'll get going in just a bit here. Beata, hello. And sorry about cat cam. I did order a new camera and it's been kind of a crazy week. I did not get around to getting it set up. I have not actually worked a lot today either because we're going camping right after this. So it's going to be a short stream today, just an hour. And then we're going to get out and go. Is this YouTube? Hello, it is YouTube. Hello, C. Grover. Yeah, so sorry cat cam's not working, but I actually do have a kitty on my lap. Vin decided that she wanted some pets when I got here. We've been loading the car up, so. Hi, Chris Burton. Hi, Deshipu. Yeah, this is the first time we're taking our kiddo camping. Hi, Bruce. Oh, my teeth. Do I have chocolate in my teeth? Fede2 asks, would you be interested if you sent the Milk 5s to me? I gotta tell you that I have way more dev boards than I know what to do with. So I think there may be better people than myself to send those to. I'll let you know if I ever do want one, but I've got like those. There were the like aux64 chips that I think are RISC-V as well. Like I got them because they were pretty cheap, but I've not used them at all. Hello, Space Pope. Okay, let's get going. Hello, everyone. My name is Scott. I go by Tannewt online. Welcome to a deep dive. I do these. I started doing these a few years ago during the pandemic, and I had a kid, and so I've not been doing them. Thanks to fpga for taking the spot. But I'm back, and what this tends to be is if you have questions, ask them, and I'll try to explain them about CircuitPython or electronics or anything really. I generally usually do have a topic in mind that I'll try to cover a little bit. I'm committing to these being an hour long, but sometimes they run 2 hours like last week did. And it's called a deep dive because we do get into very technical topics and stuff like that. So if you have questions, always feel free to just drop them in the chat, and we'll get to those. Thank you, Space Pope. Hi, Unexpected Maker. I should say that I'm paid by Adafruit to work on CircuitPython, and that's been the case for a lot of years now. I was the first person they hired to just do MicroPython stuff, which turned into CircuitPython. And if you want to support me, supporting Adafruit is the way to do it. Go to adafruit.com and pick up some cool hardware for different projects that you have in mind. And that helps Adafruit out, and they pay me, so that helps me out too. Hello, David. Honestly, Scott's deep dive is very deep for an advanced audience. Yep. And like David says, he's listening in soldering. I think a lot of people do have this on in the background as they do other things, and that's totally cool. The reason I like to do deep dives is because it gives me a chance to, like, I'm not great at written documentation, so it gives me a chance to show exactly what steps I do to do things. And there's not a lot of people that necessarily need to know the things that I'm doing, but if if they do, then it's nice and thorough. Let me turn the light. I forgot to turn the room light on, and the cat was on my lap when I remembered. So now that she's off of it, I can do it. Okay, so if you have questions, feel free to drop them in the chat. Like I said, I'm going to do no more than an hour. If for some reason I want to stop earlier, I will. But that's kind of what I'm thinking. And sorry about cat cam. I haven't done the overhead stuff yet still either. Are there any questions to get us started, or should I jump into more USB host stuff? I see C. Grover is typing on Discord. So yeah, on the chats here, this is the Adafruit Discord server, which I'm on like all week usually. And that's the URL adafru.it/discord. Nice thing is that sticks around rather than the YouTube chat that disappears. We need a camp cam now. C. Grover says, yeah, I listen in to become exposed to the terminology. Once in a while, I catch a glimmer of understanding more often as time passes. Great. Hello, Mark. All right, let's get going. So USB host is what we were talking about last week, but also what I've continued to work on. USB host is the idea that you can plug a USB device into CircuitPython rather than CircuitPython also acts as a device there. So USB host is the idea that you can use other USB devices with CircuitPython standalone without your computer. DJ Devon 3 has a question that's not related to a USB host, but let's switch over to it. One of the latest boards, Lady Ada said there were 2 different types of debugging ports. One is SWD and the other I don't know. Why would you need 2 different debugging ports on one board? I think... So typically, SWD is an ARM-specific technology. So for boards that are not ARM, like the ESP32s, you'll get JTAG. But it's usually one or the other. You don't usually have both on the same board. I don't actually watch all of the Ask an Engineers anymore because I'm really busy being a dad to a toddler. I think that it might have also been, and I think that's what DCD is talking about, is like a debug UART. So having like a separate USB to serial sort of converter so that you could do like debug logging out a different way. I think that's the case with the new ESP, for example. Like the ESP Metro, I think might do that. Okay, sorry, I noticed I had a Slack notification. What about your new show and tell? I'm not exactly sure what your my new show and tell. Oh, the trace connector? Yeah, so I can show that too. So this is a version of, wait, is this my version? Yeah. So this was a remix, so to speak, of a Metro M7. So this is the IMX 1011. I can leave it on product showcase. And what I have here is a, oh, there, I'm backwards. This connector here is an SWD+Trace. So I would still consider this like an SWD connector, but it's one that has more pins that carry trace signals along with that. And tracing is the ability to just like literally, well, you can configure what you want, what data you want to trace out. But the interesting bit to me is there's a mode. So on the Metro, like on the M7s, there's a mode where you can have it trace enough information that you can see exactly where in the code it executed, where it's executing. Like it literally just like logs enough information. I think it's like every time, you know, some code you just go from one instruction to the next, but then there's like jumps and branches. And so what it does is it logs like the results of those jumps and branches so that you can know exactly where the code's going at all times. And I haven't gotten it working, so I'll know a lot more once I get it working. But the cool thing there is that like you can do all sorts of performance analysis to know where your code's going. So that's why I remixed it to a different connector. It's kind of like a larger, it's a superset connector. It's not completely different. Bruce S says, yeah, good area to learn and improve. My Git knowledge moved from beginner to low intermediate watching Scott work the magic. Yeah, I wouldn't call myself an expert either on Git, but ever since I left Google and I've been starting to work, like I've learned a lot more about Git as well. I ask you because you seem to know debugging anything. I've never done debugging. I bet you've done debugging. I just didn't call it that. Debugging is anytime you got to figure out why something's not working. So it's a broad term. And I remember there was two things I should point out. One is there's a podcast called embedded.fm, and they just had Damien on, who's the creator of MicroPython. And the reason that came up with me is because they ask like step debugging, which is like GDB, or printf debugging, and he responded printf debugging, which is the way I would respond to. And then the other thing is that CircuitPython Day will be in 2 weeks. I had forgotten that, and it seems like the cat wants out. So hold your horses just 1 second. She's like, let me out. Okay, go. If you haven't seen Deep Dives before, Vin never likes to be in here as I'm talking. She's one of the two cats. And I got a new camera for Cat Cam. I just didn't have time to get it going. So hopefully we'll have a Cat Cam here shortly. Print the code breaks here. Yeah. I enjoy listening to you go over efficiency and performance gains. You seem to really like that stuff. Oh, performance is one of those things that you just like gotta time box yourself because you'll never finish. If you get a JTAG and even a board like a Pico, it's pretty easy to get started and just try a bit. Yeah, J-Link. And the Pico, they have like the Pico probe that works with open OCD as well, and PyOCD. What kind of camera? I got a C920S is what I got. I got a refurbed one, which is almost identical. The other one that's not been working for me is a C922, so I'm hoping that 1 digit difference is enough to make it work. Let's see. I didn't want to get a super expensive one. Like this camera here is a lot more expensive, but it's also a lot nicer. Not needed for Cat Cam. Yeah, and Fede2 says the offer is open to any CircuitPython folks, even if it's not for CircuitPython stuff. So if you have Milk 5 is interesting, let me know. Pengu says I was literally right now playing around with Pico Probe. Great. I've been working with Blackmagic. So another board I briefly showed, and I think I can do it, is this board. It's not open source. The software is, I think. It's called the OrbTrace Mini. And so what you do is you plug, I'm so backwards. You plug in your computer here, and then this is actually an FPGA. And then you can see there's 2 connectors here. One is SWD and one is the SWD+Trace. So I'm trying to move all of my debugging over to this because it's more open than a J-Link. And it can do trace. Like J-Link has a trace capable thing, but it's like $1,200 or more, and it kind of just works with their tooling. I'd rather use open tooling for that kind of stuff. But unfortunately, it supports the IMX 1060, but not the 1011, which I hadn't realized. So I'm poking around with Blackmagic, which is kind of like PyOCD and kind of like OpenOCD. If you're not a Git expert, then I'm a Git noob. Yeah. There's a lot to learn with Git. I think there's like I think I know the main path pretty well. It's like everything else that I don't necessarily know. All right, so that's 15 minutes. IMX 1060 is the big one, I think. It's the biggest of the 10 series. Yeah, okay, this is a great segue. Thank you, David. I think you gave me the segue last week, too. David says, USB host question for later. Will it be possible to be a MIDI USB host? Then combined with synth I/O and an audio output, we could have a synth for MIDI keyboard. You know, I was going to use... So I've been working on two libraries that, if you look at my GitHub, you'll see that I did the last couple days. One is the... sorry, I'm kidding. DJ Devon3 is bugging me about IMX stuff. There's an 11 series that is even more insane than the 1060s. Like the 11 series has a skew that is clocked at almost a gigahertz, which is wild. So what I was going to do is I have two libraries. So one is a descriptor library that is just like some super basic stuff to help you figure out what USB device is connected. So USB, right, is like super flexible. And the way that you know what device you have is you use descriptors to see, does it do mass storage? Does it do a CDC, like serial link? Does it do, is it a camera? Is it a keyboard or a human interface device? All of that is discoverable through descriptors. So the first library I did was one called Adafruit CircuitPython USB host descriptors. And then the second library that I did, and maybe I should start here, is Adafruit CircuitPython USB host mass storage, which is the kind of part of the USB spec that does things like USB keys. So like I have this like 16 gig no name flash drive sort of thing, and it could be cool that you could just like write to that from CircuitPython. So let me just actually start there and see if I can't just use this. So I do have a 10, actually I can unplug it enough to show. So I am using the 1060 dev kit. Let's just hope it works. I'll take all my debugging stuff off. So this is, these are, they call them EVKs. And they're insane boards that NXP creates. If you watched my videos ages ago about these, they drive me a little nuts because they're not well labeled. The newest one, the 1040, is better labeled, but they're still not that well labeled. Like they have all of the schematic designators on it, but they won't tell you like on the board, like this is the reset button. They'll just say like switch 3, and I'm like, what? So their designs are getting better, but these are really, these giant EVK boards that they have, they're really meant to give you kind of all the functionality. Whereas like something like a Metro is breaking out all the pins, but it's not doing all the functionality. So like this is for the 1060 series. So you can see it has like 2 USB ports. It's got the Ethernet jack. This might be camera, like audio. And then this is the onboard debugger. So like you don't need a J-Link. You can just use the onboard one. If you do have an external one, this is the JTAG/SWD port. It's funny, they have these like Arduino Metro headers. Like Arduino made a big enough like influence in the industry that a lot of the dev boards do have the headers. This is the chip itself, which is so funny how it's there. SD card, and then this is power input into the board. So these boards are really complicated. They run about $100, which is not too bad. You can definitely get in the multi-hundreds with dev kits like this. And this is the same chip that's like on the Teensy, for example. It's got like 2 types of flash. I think it's got SD RAM as well. So it's got a lot of different stuff going on. So that's what I've been using because it's relatively easy to debug. So what we're going to do is I'm going to... I think it's got a version of CircuitPython that works, so we'll pull that up. popped up for me. So let's look in here. And I need to switch to the desktop. All right, so this is CircuitPython. So what we can do is we can go to Code.py. And let's just open that up in here. So this is actually, I was playing around with a simple test because the descriptor, so when I prototyped it, I just wrote one Code.py that kind of did everything I wanted. And then I was trying to figure out or decided like how to split it out. So like the code I was actually writing ended up being the simple test for the mass storage library. And then also I wanted to make a separate descriptors library. And this is the simple test that I ended up for it. So let's take a look at the terminal output. Let's see if we have anything. So let's see what it's telling us at this point. So it says searching for devices, and it waits between it does that. So it's not finding anything. And the reason that it's not finding anything is because here's the thing that needs to be plugged into it. Right now it's plugged into the Beagle, but I'll actually remove the Beagle as well. And so we can play around. So this is a micro, it's a micro B, don't look at my face, micro B USB to a USB A. They're known as like OTG cables, and it's particularly nice. I had some that were right angle, but this is a straight one, and it fits better on the board, especially because, like I showed just earlier, like the host and the device USB ports are right next to each other. So having a straight one of these, I had to buy one because they had right angle ones. So DJ Devon 3 says, with USB host, no more SD card, just use a flash drive. Yep, that's the idea. Is that you could, instead of using an SD card, you'd be able to do a flash drive. I don't know which is faster. I don't know which would be faster, but yeah. So let's see how this Code.py changes when I plug some different things into it. Let's talk about descriptors. And here's my flash drive. It's a good start and test before plugging an unknown origin USB device and key into your computer. Yes, it is. Okay, so this is going to keep outputting it, but let's just Control C, and we'll go to the REPL just so it doesn't reload. So we can see here searching for devices. So we see a vendor ID and a product ID. I think the speed would be dependent on the protocol, like 2.0 versus 3.0. Yes, and in fact, 2.0 has 3 speeds. Most CircuitPython devices only support 2, which is low speed, which is 1.5 megabits per second, and then full speed, which is 12 megabits per second. And then there's also high speed, which is 480 megabits per second. Which is what the IMX RT should be able to do, but it's not doing with USB host right now. So I'm not sure why that's not working. But USB high speed gets more complicated, and then it gets more complicated the higher speeds get, basically. So let's just talk descriptors. This is super simple, and in fact, so these things come from These things come from what's known as the device descriptor. There's a number of different types of descriptors, and you can get like the USB 2.0 spec PDFs and read all about the different types. But the first one that you usually get is the device descriptor, which tells you VID, which is vendor ID, and then PID, which is product ID. And if you've ever made a board definition for CircuitPython, you know that we like to have unique USB PIDs for different boards. So usually one of the biggest hurdles for getting that is just acquiring a USB PID. But the reason is that those are kind of like the key core identifiers for what device am I talking to. And then we can see here the manufacturer. I should make it, I should spell it out. The full product name and the full serial number. And one thing that's interesting about these is the strings themselves are not part of the device descriptor. The device descriptor itself stores an index, and then you fetch a string descriptor that gets you the actual string. But this is doing that for you here. And I think, yeah, that's just the CircuitPython API. Yeah, DJ Devin 3 says you can get an open source PID if you use open source code anyway. Yeah, so there's a project that I administer stuff for called pid.codes, and that's for open source hardware and software projects. If you are a manufacturer and you have closed source or closed hardware in a product but want to use it, then I won't give it to you because the motivation of the project is to get people to open source their stuff. But if you are working on open source software for a third party's closed source hardware, I give it to you, or not vice versa, because closed source hardware, like how would you set the PID if it was closed source? That'd be a little tricky. And there's actually one PID that we granted for an open, like the tiny tape out project where you can, they're doing like community stuff into ASICs. They actually requested one, so they'll have a USB controller in there that has a pid.codes PID. Quinman16 says, "What's you doing?" We're just exploring USB device descriptors right now. We're talking more broadly about USB host functionality and the like higher level libraries that we need to do that. Maybe you could split out what you discovered in boot.py and then you use to clone a device. You could, and I think there's a project, so there's also like the security world of USB, and I think there's, like the Great Scott Gadgets folks were doing that, and they had a project for doing like man-in-the-middle sorts of USB stuff. Face Dancer is the project I think I'm thinking of. So if you're interested in doing that, like more security-oriented stuff, that's the place to look. Okay, so these are the highlights of the device descriptor. There's more there, but this is the stuff that I thought was really kind of critical and useful. And then the device descriptor will tell you how many different configurations that a device will support, and it's almost always one. I don't like, this is one thing that's interesting about specs that have been around a while is there's the big broad spec that they thought people would use, and then there's the reality of which parts actually get used. And I think in this case, like multiple configs, while they're part of the spec, I think they're rarely used. So what you do is you say like, I have 3 configurations, and you would say this one or that one or this one, and you would tell the device which one you wanted it to be. But in reality, I think it's almost always just a single configuration. So this simple test that we have here is just printing out some very basic information about that first config descriptor. So config 0, the first one, has a value of 1. They have a separate configuration value, but I think both TinyUSB and therefore CircuitPython assume that the configuration value is the index plus 1, because configuration value 0 means it doesn't have a configuration. So it's basically like shifted by 1. And then a configuration is made up of a series of interfaces, and they have interface descriptors. So the interesting bits, I think, the most interesting bits are class and subclass. So class 8 and subclass 6. And there's actually a good, let me pull up a browser here. USB.org. Class codes. Yeah, so let's take a look at this. So this is on the USB.org website. And so if we look here, base class, and there's classes in both devices and interfaces. but we can see here the base class 8 is mass storage. And if we zip down to there, it says the base class is defined for the mass storage device class spec on the website. That other spec defines the usable set of subclass and protocol values. So that's what we're seeing here, is we're seeing this interface is a mass storage interface, and the subclass is 6. And if we want to figure out what the 6 means, we go to the specific mass storage device spec. That's, I think, pretty common, like this pair of stuff. So it actually really doesn't matter. You can just expect that they're both that. And then the other thing that's part of that is that USB uses a notion of endpoints as a way, as like a matter of like addressing where data goes, or what kind of data it is. So you have a device and it has a bunch of endpoints, and the endpoints are the thing that you read and write to. They'll either be writable or readable. Like so endpoints have a direction, and that's what we're printing out here, is that for this mass storage interface, the in endpoint has the address 81, and the 8 actually also tells you that it's in, and then the out endpoint is 2. And that's relative to the host computer, I think. So in would be data going from the device to the host, and then out would be from the host to the device. And if you've ever seen errors in CircuitPython about running out of endpoints, that's kind of what this is talking about, is that how many endpoints do you have in this descriptor, and does the hardware have like hardware queues for each of them that it could actually use. So let's just, I was thinking, let's do some other USB devices that I have on the table here. And the one that I was thinking of would be a CircuitPython device. I had one I was using for an example, and I do have a bunch. The question is do I have the USB cables to plug them in? So I have a circuit playground here, but I need an A back to micro. Here we go. I did find one on my desk. Okay, so I'm going to unplug the mass storage device, unplug the thumb drive, and let's plug in a CircuitPython. Well, I assume there's CircuitPython on this circuit playground. Yeah, it's blinking at me. It's playing tones. I don't know if you can hear it. Okay. Ooh, boy. All right. So we enumerated here, and let's do the same trick of pulling up the REPL so it doesn't keep going. So, okay, so here we are. Now we're looking at the USB descriptor from a CircuitPython device. So we have a vendor ID 239A, that's Adafruit's vendor ID, and then the product ID here is 8019. And we generally allocate 3 product IDs per hardware device. One is used for the bootloader, one is used for Arduino, and one is used for CircuitPython. So this product ID here will be unique to Circuit Playground Expresses and also to CircuitPython. You can see the manufacturer and the product. That is really like in the board def. That's where it comes from. And then the serial number is coming from the unique ID that the chip has, however the chip determines it. Coinman16 says, will you be posting your USB host reading guide on Adafruit? I don't tend to write learn guides, so it probably won't be a learn guide from me. That doesn't mean that there aren't other Adafruit folks that will do USB host related learn guides kind of like downstream of me. But right now, like, this is the best you get with the stream about it. Yep, so that's that. And Beata says, I was wondering about the product IDs being different. Yeah, so the product IDs are like not something that's burned in. It's just something that the software knows. So there's only, well, I think there's only one configuration. I'm almost positive. So here's again the only configuration, but now you can see that there are 6 different interfaces, which is a lot. And first, let's actually see that we have the 8.6 one, which is the mass storage. So we have a mass storage interface. That's the CircuitPy drive. And that's why if you're looking at an ESP32, we can't do it because it doesn't actually have native USB. So let's just take a peek at, let me move this over here, and we'll just do a quick look at the other stuff here. So one is audio, and we can see that interface 4 is audio, and also interface 5. So this is your MIDI functionality for CircuitPython. So we've covered 8, 1, and now we have 2, 3, and A. So CDC here, 2. This is your serial. That's your serial link. And it's interesting because it's only an in endpoint, not an out endpoint. And I'm not sure why that is. Oh, here we go. So there's this communications and CDC control, but then there's also CDC data. So that's the A. So this class 2 and this class A, this is what implements your serial connection. So we have serial, we have mass storage, and we have audio. And the last one here then would be human interface device. So this is the interface that you allow CircuitPython to be a mouse and a keyboard. And there are separate human interface device descriptors as well that this library is not dealing with, but would tell you like how many keys can be pressed and what kind of state there is. Like the HID descriptors are really complicated. They're very, very complicated. And then as Fede2 is pointing out, that you can see here that device 9 is actually a hub. So a USB hub actually is something that the host can address on its own as well. And I've only just begun kind of understanding how that works. But you can do things like turn power off and on to like different ports on a USB hub, for example. And that's just done over USB because the hub itself is a device on the USB bus as well. Okay, so that's that. Let's keep going. I have maybe a couple other things that would be interesting. One that's relevant for David, because it's within reach with me sitting here, is this one. So it's a MIDI keyboard. And if we look on the back, we can see that it has a, sorry, let me switch to product showcase where it won't eye track. So we see that there's a USB plug here. And let's just take a look at that. There's also regular MIDI and sync signals and stuff. But if we just unplug this circuit playground, and I'll just plug, this is the one that goes to the Python device. We'll plug in the Arturia, and we can see, oh, we have power. The buttons are lighting up. And you know what? I actually do have test script for this already. So let's Control D again, and then we'll Control C and stop ourselves. So now we can see here, and I should pad these numbers so that they're always 4 digits. But we can see the vendor ID and the product ID. We can see that it's Arturia, and that it's a key step 32, and that the serial number is 1A, which sounds suspicious. And it's probably not unique per device, but you never know. And I think I have opened this up, and it's an STM32 of some sort on the chip itself, because I'm weird like that. And then we can see here that we have 2 interfaces again. We have a 1 and they're both 1, but they're different subclasses. And in fact, we didn't look here. Oh yeah, so it says the audio device class spec is there. So that is that. And so if you were, and maybe we should just try it. Okay. So Beata says, I was having fun with some hubs years back, all of the same retail product, but some could do power, but some could not. Okay, so some hubs can't do power on and off. But I'm not sure. Crinman16 says, because I have a Feather RP2040 with USB host that I wanted to make a USB keyboard remapper. Yeah, so maybe that's what we should do before I get down this path, because this is audio, so it won't be the same as a USB keyboard. And a USB keyboard is kind of tricky because CircuitPython will automatically do it. So if I unplug, I'll unplug the MIDI keyboard, and I've got this like wireless keyboard here that has a dongle, so it's not like Bluetooth or anything, it's just like some random 2.4 gigahertz thing. So if I plug it in and hit Control D, we'll see that we get class 3, which is HID, but now on here I can do Control C and like actually do stuff. But I should let's see if I can't just write while true. Oh, I missed a letter. Oh, I'm gonna lose the keyboard the moment that I yeah. It gets a little tricky. Should we see if something that I haven't tested but should test works? Okay, so let's duplicate this. Yeah, there's already a project called HID Remaper, I think, that can work. Code descriptor. Yeah, Crinman16, I suggest getting on the Discord. There's folks that are interested in this too. And there is a project for it. So let's open Code.py and let's start tweaking some things. So what I like to do is if device, so remember you could have a hub plugged in, so you may not have found the device. So let's say while we don't have a device, and we want to keep track of the in endpoint equals 0. 0 is the control endpoint. So in this case, 0 is okay to do. We would say, okay, we don't actually care about the configuration, but we could say if interface class equals HID. Where did my terminal go? So there's two interfaces here, so I'm not sure which one is going to be the one we want, unfortunately. We could just pick the second one. One's probably mouse and one's probably keyboard. So and interface subclass equals 1. Is that what it was? Yeah. And let's not make this ambiguous. Let's say HID device. Otherwise we have two names for devices. So we say if interface class equals 3 and interface subclass equals 1, we say HID device equals device, and then what we could say is if it's an in endpoint, so from the device to the host, if HID device, then we could say in endpoint equals endpoint address, and that will say print found hid device and in endpoint. Oh, and the time.sleep. So once we find the endpoint, we could break, and that would make it faster. Except we're trying to break 2. Oops. So we could say if not device. Oh, and then what I also realized is that you don't actually have to do it this way unless you want full control. You could also just say while true, print input, or sys.stdin.read 1. I think is what it is. And maybe we wrapper it so it doesn't mess us up. And we need to import sys. So because so CircuitPython automatically supports keyboards, and keyboards produce key events like key codes, but they don't give you like actual ASCII or Unicode characters. So there's an extra step that translates hid report events into serial stream. So what I'm doing here is it's the same serial stream that we would get over the serial link. So if I just say HI, like that's what I'm typing in here. But now if I go back to my keyboard and I type HELLO, and I don't know why it auto-reloaded, but I don't think it's pressing the O key. Maybe it is. Now it's not working anymore. Uh-oh. I crashed it. I wonder if it's fully crashed. Nope. Just the keyboard input's not working. I'm not sure why. There are bugs in USB host still, folks. And we have 10 more minutes or so, so if you have any more questions, now's the time to ask them. But yeah, so if you want just like the characters themselves, you could just use like the standard in. I don't know why this is broken, but ideally we'll fix it before it's stable. So that's one way to go. And the other way to go is if we comment out this, I think what we need to do is we need to do device detach from kernel. And I don't know if this works. I've been meaning to test it. But if we pull up the CircuitPython docs, and we go to core modules, and we go all the way down to USB, and this mirrors the Pi USB API. It's just a subset of it. So this is what we're using to find the device. Here's like the device descriptor stuff. Quidman 16, we don't have a learn guide for this yet. This is all very new. Yeah, it's all very new. There's the Arduino stuff might be a bit further along. So detach kernel driver is what we want. And we actually need the interface for it as well. Detach kernel interface. And we'll say interface number. Oh. Hid interface number equals interface number And so we'll say like, hey, stop using that for the internal CircuitPython stuff. And then we can say report. They're called HID reports usually. And you can do device.read. And we can reference the low-level docs. So we would give it the endpoint and then a buffer. And the HID report descriptors will tell you how big they are, but they tend to be 8 bytes. So we'll do buff equals byte array 8. And so we'll say in endpoint and then buff. And report is not right. Size. And then what we do is we print buff. And we do just the size of it. So if it's less than 8 bytes, which it shouldn't be, this will only print the stuff. So let's see what that does. We might need to restart it too. Is that not what it's called? Detached kernel interface. Detached kernel driver. And I don't actually know that this works. We'll see. No configuration set. So we also have to say device set configuration. And if you don't give it anything, it'll do the first one. All right, so we managed to do a read from that endpoint. So if I press, ooh, it is actually working. Awesome. So I'm pressing the B key. So this 5 here is the B key. So the standard HID report layout for keyboards tends to be the first 2 bytes are a mask of your modifier keys. So your Alt, your Shift, your Control end up here. And then you get the key codes of 6 pressed keys after that. And now we're crashed. So like I said, it's early days for USB host still. And then, yeah, so you can see 19 here is a different key. I forget which. But so this would give you like low-level access to what the HID device is doing. I don't know what this USB error is, but we could see if it works again. We have some issues about resetting. It's unfortunate. Like we were probably calling read here when it got interrupted, and like we don't cleanly stop the read sort of stuff. So yeah, there's bugs there, and please file issues if you're playing around the USB host and you run into this sort of stuff. For now, what I'll do is I'm just going to eject the drive, and I'm just going to restart it. And we're just about to wrap up anyway, because I gotta go. I gotta go camp. Oh, okay, Control D. So we got a USB error again, and I'm not sure why. But you can see that it is working internally to CircuitPython still, so there's some work to be done there. But yeah, so that's, oh, the delete key doesn't work. Oh, that's delete, not backspace. Interesting, there's 2 separate ones. Enter. Anyway, okay, so that's a brief tour of the new USB host descriptor library and the basics of descriptors and discovering the endpoints that you want to read or write to. Super basic. Generally, my approach to USB host on CircuitPython is like assuming that you've already learned a lot about the device that you're talking to, probably from like a more full computer. There's a lot of like variables and state and stuff that's in descriptors, and full libraries will have all of those different bits and bobs. But storing strings is actually really, like variable names is actually like pretty large. So I'm trying to keep the USB host libraries for CircuitPython super minimal and really like focused on exactly like the use cases that people are going to do. So yeah, check those out. I didn't get to the mass storage demo, but you can use a USB thumb drive using the VFS FAT thing. And so you could read and write files to that, all from your user code. It just does reads and writes to the endpoints. And then the like SCSI protocol that the mass storage stuff uses too. But yeah, that's it. Thanks again for watching Deep Dive. I should be here next week as well. It's been super fun. If you want to support me, support Adafruit by going to adafruit.com and purchasing stuff. As Quinman points out, we do have a feather that has a native USB-A on it, which makes it really easy to plug stuff into. If you were watching last week, I was hitting a bug, and I haven't gotten back to debugging that, but I haven't fixed it as far as I know. But then again, TAC tried to reproduce it and wasn't able to, so it might just be my weird setup. Anyway, that's an example of stuff you can buy from Adafruit.com. CircuitPython is broader than Adafruit stuff, so it is supported by other boards as well. Although development is primarily driven by Adafruit-funded folks. CircuitPython Day, 2 weeks from today. I'm planning on streaming, plus we'll have a bunch of other streams as well. If you have ideas for CircuitPython Day, let us know. I think you can email circuitpythonday@adafruit.com. And yeah, I should be here next week as far as I know. So I'll see you all next week. Discord is adafru.it/discord. Lots of cool people there to check out and hang out and help out. So with that, have a great weekend, everybody. I'll talk to you next week when I'm back from my camping trip. And sorry, no cat cam again.